You write clean scripts, you automate, you build. It works perfectly on your machine, but the hardware remains largely invisible until you ask that exact same code to process a million rows of data, and the system chokes. One line of code can trigger a massive, silent tax on your processor. There is a canyon between knowing Python syntax and engineering a scalable solution. Moving forward requires seeing past the script and into the system itself. To build software that survives, we have to look at the physical architecture underneath the glowing screen. This is the focus of Chapter 2, Arrays and the Grid of Contiguous Memory, from the book Data Structures and Algorithms in Python for Beginners. We strip away the academic jargon to look at the literal physics of computer memory banks. An array is not an abstract concept. It is a rigid, unbroken mapping of physical hardware that forces your code to obey the limitations of the machine. Think of a perfectly straight, unbroken street of connected houses with no empty lots. In this environment, you have to account for the amortized cost, the hidden penalty that hits your application the moment the grid reaches its invisible capacity. You witness the mechanical reality of a digital forklift desperately shifting thousands of records just to make room for one new item. This understanding of hardware strain is exactly what top-tier tech companies look for when they interview for engineering roles. But when you master these physical constraints, you stop fighting the hardware. You learn to deploy mathematical pointer patterns to exploit the machine for speed. You move from heavy lifting to active pointers scanning the memory grid, the two-pointer technique, the sliding window pattern. And then there is the explosive mathematical power of the binary search. Mastering these specific choreographies is the secret to acing whiteboard interviews at Google, Meta, and Amazon. The era of just making it work is over. The future belongs to the builders who architect optimized, scalable systems. This journey leads from simple arrays to complex hierarchies, neural networks, and dynamic programming. This is the manual that provides the architectural blueprints. Authors Sharanam Shah and Vaishali Shah deconstruct the math behind the magic to show you how these systems are actually built. Bridge the gap. Think like an engineer. Download the professional repository and find more transformative titles at sharanamshah.com.